Hi and welcome to your next chemistry lesson. In this lesson, we will look at the structure of an atom. Now you might recall that an atom is the smallest part of a pure substance that still retains the same properties of that substance. Pure substances are called elements. And what an atom is the smallest part of that pure substance that still has the same properties as that element. Now that doesn't mean an atom cannot be broken down into smaller pieces. As we have seen, that an atom consists of three things. It consists of protons, neutrons, and electrons. Okay. Now, protons are what we call positive charges, and it becomes the very definition of what is a positive charge. An electron is attracted by protons. They have this sort of attractive force existing between it, and it becomes the definition of a negative charge. Now, neutrons are not attracted or repelled by any one of these two, and it is called neutrons because it is the neutral charge. Let's call it neutral charge like that. Okay, now the protons and the neutrons, these two together, they exist in the nucleus of an atom. Now, even though the nucleus is the smallest part of the atom, that is where all of the atom's mass exists. Okay? Now, around that atom, around it, we get around the nucleus, we get what we call the electron cloud. Okay, so there's the electron cloud around the nucleus. And in this electron cloud, we encounter the electrons. Okay, so the electrons exist in this cloud. And at any moment, they can be at a certain position traveling in that electron cloud. Okay, now that is more or less where you will encounter them. Now a little bit more detail. The first thing I want to tell you is that the number of protons in an atom is always the same. Okay, what I mean by that, per element, of course. So if I have, let's take something you might know. Let's take iron. Okay, the symbol for iron is Fe. Two iron atoms will always have the same number of protons. Now, iron itself has 26 protons. Okay, that means if I were to look in this neutron, in this nucleus and I were to count the number of protons, I would count 26 protons. Any other iron atom will have the same number of protons. It might not have the same number of neutrons, though it is probable and very likely that it does have the same number of neutrons in the nucleus. Okay, and before I actually get there, this number of protons is called the atomic number. The atomic number. Okay, and on the periodic table, that's a table where we find all of the elements with their information. They are sequenced, they are placed in an increasing order of their atomic numbers. So for example, the first one is hydrogen. Hydrogen has one proton in his nucleus. The next one is helium. Helium has two in his, an atomic number of 2, so he has 2 protons in his nucleus. The next one is lithium. Okay, lithium has 3. So notice that as I get a proton, it actually changes what type of element it is. That's very interesting. Now, as I said, the number of neutrons are likely to be the same. Okay, now, it's very likely that if you have 26 protons, you have 26 neutrons. But the sum of these two, if I add these two, Because they make up all of the mass, the nucleus is what gives an atom its mass. There's very little mass in the electron cloud. Because of that, when I add these two, they give me the atomic mass. Atomic mass. So, my atomic mass is the sum of protons and neutrons. But the problem is, two different atoms might have a different number of neutrons. So for example, I might have some iron have 26, all iron have 26 protons, but it might have 25 neutrons. That would make its atomic mass to be 51. Okay, and another one might have 20, well, it always has 26 protons, but it might have 26 neutrons as well. So that one will have an atomic mass of 52. And another one will have 26 protons, but it might have, I don't know, 24 neutrons. So it has an atomic mass of 50. So what the scientists have done is they have gone and looked at these different ones, and they call these isotopes. Isotopes mean it is the same atom, but they have different number of neutrons in their nucleus. Now they've gone and looked at these isotopes, and they have gone and looked in the environment and tried to see what percentage is the isotope 52. Okay, what percentage is there of this one, and what percentage is there of this one, and what percentage is there of this one, and they have gone and worked out a weighted average, and so that you find that for iron specifically, the weighted average is 56. Which is interesting because that would suggest that most of the number of neutrons in iron is actually 30. Okay? Because 26 plus 30 gives me the 56. Okay? So he has actually, in our universe, in our observable universe, iron has quite a bit more neutrons in its nucleus than it has protons. That's very interesting. I find that interesting. Hope you do as well. Okay. Now, when it comes to the number of electrons in an atom, electrons can be shared with other atoms. It can be given away. You can add more electrons. Electrons aren't fixed, while protons and neutrons are usually fixed in the nucleus. They can't change. So the electron, however, can be changed, the number of electrons. Now, a neutral element, if I have a neutral element, that would mean that I have the same number of protons than I would have neutrons. Sorry, not neutrons, electrons. Okay. Which means that in a neutral atom, a neutral iron atom will also have 26 electrons. Okay. But since that is what changes, this change in electrons is what causes atoms to bond to other atoms. Because the law of electrostatics, the law of electrostatics, the most basic law of electrostatics, tells us that like charges repel. Okay, in other words, a proton will repel other protons and opposite charges attract. Opposite charges attract. So in other words, a positive charge will be attracted by a negative charge. Okay, so what happens is that the moment I have less electrons than protons, it means my protons are in excess, giving my atom a positive charge. If I have a positive charged atom and somewhere else I have a negatively charged atom, they will be attracted to one another, creating a bond between atoms. And that's why we are not just floating around atoms in this universe. There are attractive forces in the building blocks that make us up, that keep us together. And that is because we have more protons in one type of atom, or in one atom, and a negative charge in another atom, causing them to be attracted to one another and keeping together. Okay, so in the next video I will look at the electron cloud and how we will encounter electrons in that electron cloud and the orbits they travel in. I'll see you in that video.